Today's lecture is about building Dapp. Dapp means decentralized application. Actually, in this domain, blockchain domain, every developers said Dapp. Dapp instead of other style terms like Web3 application or blockchain-based application, just Dapp, even though it is not decentralized. So I will use Dapp in common. So this lecture focus on how to build Dapp, and we will handle the entire process of building Dapp. Today's lecture's objective is understanding the entire process of building Dapp, and also I'd like to give you some ability to develop and deploy Dapp samples. To be honest, starting to build Dapp is not that trivial, because there are many things to know. So, and the environment is a little bit complicated. So, if we want to learn Dapp samples as a beginner, it's also very difficult. So after this lecture, I hope you can deploy and test Dapp samples. So you will learn various development tools. So this lecture will cover Dapp development process and KAIST contract deployment. You will use local environment at first, and then you will deploy your contract to testnet, and then finally you will deploy your contract to mainnet Ethereum. So it is KAIST contract deployment. And you will learn Remix, Truffle and Ganache and Hardhead and EDOS.js, so many things. And also we will handle two different Dapp samples, online borrowing and token. I'd like to give some notes before we get started. Today's lecture is geared toward beginners. So maybe there are some experts in this class. They already know all these technology or all these skills, but many of students and auditors don't know how to start building Dapp. So these lectures is for beginners, and the goal is let them try out Dapp samples. And today's lecture contains a lot of content. It's my intention, because I hope you use it as a resource for self-study later. So today's I cannot explain all details of programming. So you can use this material for your self-study. And to be honest, I'm not a seasoned Dapp developer. Especially, I'm not good at developing front-end part, JavaScript and web framework, a lot of web frameworks. So I don't know how to develop web framework, web front-end well. So don't hesitate to comment if there are some errors. And feel free to answer questions if you know in chat box. So I summarized references I used to prepare this class, this lecture. So these resources are selected by me. So most resources come from official website of very important organization like Ethereum Foundation or MetaMask or Solidity and ETH.js. So you can understand their how you can use their library or their tools, and there are many good examples from Ethereum Foundation or YouTubers, so you can learn Solidity and Dapp development from them. So the first example is simple Barrett Dapp. Barrett is boring. So it is the example from a book of Blockchain in Action. Actually, I studied this book 2 years ago, maybe. So at that time, it was new, and it was a very good book. But recently, I realized it's not working now, because this book is a little bit old, so many things are changed. So I modified their dApps to work recent environment. But I think Barrett online boring is very good example to understand how to build dApp and how to work with blockchain. So it is very good example, and it's very simple and easy to understand. So it is good for walk through the entire process of dApp development. So you can clone the code from this URL, and then you can test and deploy all these things. I tested all these things, so it will work. So let's start. Our use case is online boring. So as I said, you have to define problem exactly before starting programming. So what is problem? Online boring is very convenient, but it's also highly susceptible to manipulation, because it is online and it is digital. So we cannot believe someone will manipulate the result, because digital data is can be easily copyable and easily manipulated. So what is the solution? We can use blockchain to implement transparent and tamper-proof online boring, because blockchain is immutable. So, and then we have to ask this question: why blockchain? Without blockchain, we can implement online boring with traditional way. So maybe we can implement a web version of online boring. But in this case, there are some problems, like this problem. So boring authority can manipulate, like for this one-on-one. So, and also people cannot trust boring result, and pressure. There may be some pressure on boring authorities. So so we need blockchain. When we implement online boring with blockchain and smart contracts, and no one can modify boring logics, and also no one can manipulate boring data, boring result. So we can increase the trust in online boring, even if you don't trust the boring authority. So it is not a decentralized online boring. We just use blockchain as a foundation layer to improve trust. So someone will be a chairperson, and someone will control the page change. But even chairperson cannot change the result. Okay, let's imagine to implement online boring in traditional way. Maybe we will use web server like React, and we will use MySQL as a database, and we put polling result and polling data into database, and we will make admin dashboard to control this database and web server and process. So these are manipulation points. Admin can control this database and web server and data and process. So data and process can be manipulated. But if we add blockchain part to store voting data and voting logic, we can achieve unmanipulable online voting. So we can separate two different parts. So the key point is separating on-chain data and off-chain data. We will store important data like voting data and voting results into blockchain. It is on-chain data, and we don't store any other data which are not important, such as voter profile or proposal data. We will store this data into off-chain data, off-chain storage like database or file system. Okay, let's take a look at the entire process. This is our the entire process. We have 7 different pages to develop the app. Design, and then developing smart contract with Remix in simulated environment, and then we will deploy and test the smart contract in local environment like local PC and laptop. And then we have to develop a web application part. And we after getting a smart contract part and web application part, we can deploy and test all these components, all this code into local environment. And then we move to testnet to deploy and test all these components. And finally, we can do deployment and test in Ethereum mainnet. So you can think mainnet as a production environment and testnet as a staging environment and local environment as a development environment. So development and staging and production. So it's very similar to traditional development process. It is the app development environment. So based on Truffle and Web3.js. So in the first example, we will use Truffle and Web3.js, and then next example will use Hardhat and Ethers.js. So after this class, you will learn all this framework and JavaScript library. Okay, there are many components: client part, user part, and server part. Web server will run web application, and also Ethereum part. Ethereum part has different environment like Remix and local environment, testnet and mainnet, and code editor and development environment like Truffle. This lecture, you will learn toolsets like this. I will use this toolset. So in this lecture, we will make 3 different file code. So web user interface, index.html, and web application app.js, because we use Express. and smart contract borrowed.sol. So that's it. We just program these three code. So the first step is design. Design is very important. You have to define what problem is as exactly as possible, because if you don't define problem exactly, you maybe after a few months later you realized you defined a problem not exactly, so you need to change your whole code. So it's very important. So problem statement, this is the problem statement of online borrowed application. So you can read this problem statement. I will give 2 minutes, 1 minute, 1 or 2 minutes. So I think it is a very good problem statement because it contains some limitation, constraints. So we need this kind of constraints to run this application. So with this problem statement, we have to analyze the problem. So then we can extract roles and asset data and statements and events. So you can use a use case diagram from UML. So you can define 3 different roles: borrower, chairperson, and anybody to request the result. And rules, it defines constraints. Only chairperson can register voters, and only chairperson can change voting page, and only register the voters can vote, and the respective operations can be performed only in the corresponding page. So this is very important because this will be translated into modifier of solidity, and this modifier will allow to call a function or not. So, and there are many assets like voters and chairperson and proposer, and we have 4 different states: init state and registration and voting page and done page. And we will emit some events like registration started and voting started and voting done. So some of you already be familiar with this use case diagram. Is very common in computer science and software engineering, UML notification. So we can use this use case diagram to identify who users are and what assets are. So there are 3 persons, 3 users, and we can define 3 use case: register and vote and request winner. This is finite state machine diagram, FSM diagram. This example has very simple state transition scenario. So just one single direction from init, registration, and voting and done. So just only a chairperson can change this page. But other applications may have very complicated states. So I recommend you try to you try to define this FSM diagram, when you define FSM diagram, state transition, you can analyze your problem, and then you can make phase and steps to learn your code, so it can reduce the mistake and errors. So it's very simple. And finally, we will write contract diagram. It's similar to KAIST diagram, but in this case, it is contract diagram. Contract name is Barrett, and data, event, modifier, functions. We define the 4 different sections. So the first part, data. So we define data assets and event and modifier to constraint to limit function call and functions. After writing contract diagram, we are ready to program Solidity. Okay. Next step is developing smart contract with Remix. It's a Remix. I recommend to use Remix at first because it is very convenient. You don't need to install any application and any tools to use Remix. Remix is an online development environment to develop smart contract. You can just access Limit website, and then you program your code, and Remix website remember your program, your code. So after that, you connect to Remix, you can see your code in Remix website. So it's very convenient, to be honest. So this is the data part. This example is very good because in this data part, you can understand many different data types of Solidity, structure type and mapping type and array and enumerate. So it's very simple to understand. So I don't explain in line by line. So okay, so skip this step. And state transition, I defined the function advanced page. This page define the transition of each page. And then when phase transition happened, this code will emit event. And this event will be recorded into blockchain and will be returned to application. So application can know the state, the page is changed. And event can be used as a logo data. Modifier I think it is very important. Modifier is a special type of Solidity function. Actually, it is function, which is used to modify the behavior of other functions. So limit to call a function. So it is usually used to check that a certain condition is met before allowing the function to execute. So I defined 3 different modifiers: only chair, and valid border, and valid page. You can understand what this modifier is about. So for example, only chair modifier will be called before register function is called. So when we call register function, this function will call valid page and only chair. So valid page modifier will check this page is a registration page. And if not, this modifier will revert, and transaction will be reverted with a message, not the requirement page. And only chair modifier will check the caller is a chairperson. So you can implement this code inside the register function, but in this, if you write modifier that logic, the condition check logic inside function, you cannot differentiate. You cannot distinguish. This is between the logics and modifier. So the reason why we use modifier, it is very easy to understand the condition or the constraints, and it is a rules to run each functions and call a smart contract. And Solidity provides some functions for error handling: require, revert, and assert. Require is a kind of gate check functions to verify inputs and conditions before execution. So you have to use require before advance your business logic inside a function. If failed unused gas is returned to the caller and state is reverted to the original state. So you don't need to worry about the change of state in blockchain. And revert is very identical to require without evaluating any condition. So you can use revert inside the function, inside the business logic, complicated business logic. If you think the condition is not good, is not correct, you can call revert to revert, and then if revert is called, unused gas is returned, and also blockchain state will be reverted to original state. Assert is used to check for code that should never be false. So you should be cautious to use assert, because when assert is called, your gas fee will be consumed, so you cannot return unused gas. So usually we have to use require and revert for many cases to check condition, and assert should be used for non-normal unusual case. So this is the part of functions. You can see this function is not that difficult to understand. So as you can see, we use the require function in line 78 and 79 to check this sender is already voted or not, and the proposal number from argument is correct or not. So it's very simple. And one more thing to note is that message sender. You will see message sender a lot in Solidity code. Message sender is inside the variable from Solidity. So message sender bring the address of caller. So as you can see, line number 45, this is constructor. So when a contract owner will call this constructor when deploying this contract. So message sender will be a constructor owner. But when both function is called, the message sender will be changed to any address, any accounts. So message sender may be a chairperson or any other borders. So you have to distinguish who message sender is. Okay. After writing a smart contract, you need to test this contract to deploy. It's very important process. Testing is very important because when you deploy a smart contract, you cannot modify, you cannot remove your smart contract. So it's very important to test your smart contract. So you need to write to different types of testing: positive testing and negative testing. Positive testing is verifying the behavior works as expected given a valid input. On contrary, negative testing is checking and validating to catch errors and revert functions when given invalid input. Okay, so I will show you the video. I pre-recorded a video to demonstration because I don't want to waste the time on malfunction on demonstration. So I will share the video.
Okay, this is a remix, and you can see our Barrett smart contract in Solidity. So this is data part and modifiers and events, and then you can see several functions like this. So let's compile this Barrett smart contract. Compile, and we successfully compiled, and then this is deployment panel to deploy our smart contract. You can choose other blockchain network or Linux simulated environment. So you just choose Linux VM, and we specify initialize the parameter the number of proposal as 4, and then deploy. So we successfully deployed our smart contract in Linux VM. You can see deployed contract in this panel. Okay, so you can easily test your smart contract with deployed contract in Remix. So current phase is just one. It is registration phase. Okay, you have to register several address to test this smart contract. So I can choose this one and copy, and then you have to return to the main account to deploy this smart contract. This contract is a chairperson. So register, we successfully registered this account, and then another account, copy and return to chairperson, and copy and register. Okay, we registered two other accounts, and we advance our page to both. Okay, so current page is 2, boarding page. So we are this is chairperson account, so chairperson will vote to 1 vote, and then change the account to the second one, and then vote 0, and the third one vote 1. Okay, three accounts already voted, so we can move our page to vote done, but we got the error because currently this account is not the owner of contract. So it means this account is not a chairperson. So we have to change our account to chairperson, and then again we can advance page. So we successfully changed the page to done, and finally we can request the winner. So winning proposal is number 1. So you can easily test your smart contract with Remix because you can put parameter into functions, and then you can see that result from terminal Remix terminal console like this. So when we request the winner, that function emit some event both done and the result with the result like this. So you can check the status and the result and event with this Remix terminal.
Okay, go back to the slide. Okay, you see the Remix demonstration. So I think it is very easy to use Remix, and it's very safe. You don't need to worry about real blockchain or tools, just use and test. Okay, and next step is deploy and test the smart contract in local environment. Actually, Remix is not local environment. They use their Remix VM in their server. So it is simulated environment of Ethereum. So next step is to deploy and test your smart contract in local computer. So from now on, we have to use some tools, many tools. So Truffle is a Dapp development framework. It is the first one in Ethereum environment. So it was very popular and famous. So this Truffle is provide some tools like compiler of Solidity code and deployment tool and automated contract testing tools and script. So there are many things. And Truffle suite contains Ganache. So Ganache is a local test chain to deploy and test your contract in local computer. So you can think Ganache as a personal Ethereum blockchain. So you will see this Ganache is running. And I used Visual Studio Code. It's very popular code editor, and you can install some useful extension for programming Solidity like this. So let's start to use Truffle to develop a smart contract and deploy and test. So initially, you have to install Truffle, and when you run Truffle in it, you will get this temporary template folders. So that's the starting point to deploy your smart contract. But I already write every script and configuration file into GitHub. So when you clone my GitHub code, you don't need to override. You don't need to override existing files like configuration file or script file. So it is kind of a note. And then we can compile this Solidity file with Truffle compile, and we have to modify Truffle config.js to deploy our smart contract to local PC. So Truffle config.js define local network, in this case Ganache. So host and port. And then you need to write deploy contracts .js. It is a script for deploying your Barrett contract. So as you can see, this script defines the initial parameters as for, and then run Ganache and deploy contract with Truffle migrate. That's simple. So when you clone code from GitHub, you just type this command and you can see the result. And then after deploying your smart contract into Ganache chain, you need to test a lot. So Truffle already provides systematic testing framework like Mocha and Chai for assertion. So you can write testing script with JavaScript or Solidity. In my case, I used JavaScript, and you need to understand 3 different functions. For each function, initialize the contract and establishes the base condition of the execution. So you will test a unit test with it function. It function means independent test. So it is a unit test. So every unit test before each will be called, and then contract will be initialized. So you can test some functions with initialized contract. And describe function is a composite of unit test. So you can make some composite test with describe function, including many it functions. It is the part of baratest.js. So you can see boring test, describe a boring function. In this function, in this function, we have 3 different it functions. So 3 different unit tests. And describe is whenever describe is called, before each of describe function will be called. So initialize something like register account 1 and account 2, and then in each unit test we'll use this account to test both functions. After writing this testing script, you can run truffle test and you will get this result. So this test contains positive test and negative test. Okay, I'd like to show you a recorded video about this. This video shows deploying and testing smart contract. Okay, please bear me.
This video shows deploying and testing smart contract with truffle and ganache in local environment. We already wrote Barrett smart contract and we copied that code into Barrett.sr like this. Okay, let's compile this smart contract with truffle compile. Before compiling this smart contract, we already set up the basic smart folders with truffle init and npm init. Okay, then we have to deploy this smart contract into Ganache chain. So firstly, we will modify truffle config.js to add this part. This is for this is configuration for local Ganache chain, and also we have to add this file deploy contract.js, and this file will deploy Barra smart contract with the initial parameter 4, so the number of proposal. Okay, then we have to run Ganache chain. So I already make my own Barrett Ganache chain. So this Ganache chain provides 10 different accounts, and I already tested that smart contract with some accounts. Okay, finally we are ready to deploy our smart contract. So we can truffle migrate reset. So we can reset previous deployment of our smart contract with reset argument. This argument just work on local environment, and then finally we deployed our Barra smart contract. So this is the smart contract address, and you can check Ganache chain. So transactions, there are two different transactions. It is smart contract transaction and migration core. So contracts are successfully deployed. The next step is to test this smart contract. So we have to write this test code, paratest.js, like this, and then we can run truffle test to test this code. Truffle test. It automatically tests all test script. So you can see which unit test pass or fail. So it's a very convenient way to develop smart contract in test-driven development way. there are positive tests and negative tests. So 15 tests passed. So it's done. We developed our smart contract in local environment.
Okay, let's move on to next step. Okay, next is we done to develop a smart contract in local environment, and next step is developing web application. So it's also not trivial. How to call smart contract in various application types. There are a lot of different types of application, like web application and mobile application and game application. Today's lecture, we will focus on web application. So if you want to know how to interact with other application, you can find out on the internet. So we already used Remix and Truffle to interact with the blockchain using Web3.js, but we will develop web application with Node.js and Express. So we need some tools to access to blockchain in this web application. So smart contract and blockchain part we are done. So we move to web application part, and then we need to develop web user interface, index.html and app.js, and we will see this final web page. What's for dinner today after this class? So it's not serious boring, but to me it's very important. I don't like someone manipulate this boring. So this web page is very simple, but it's very understandable. So upper part is about boring and register and advanced page and request winner part. So that is the good way to implement web page in a simple way. So you can implement each user interface for a single smart contract call, function call. So it is a very easy way, and then you can improve your web page or web user interface after testing. Okay, as I said, I use Node.js and Express. So npm init, then you don't need to npm init because I already done all this initialization in my code, and programming index.html and app.js, and then npm start, and as you can see, yeah, okay. This is web user interface. I don't explain index.html. It is not about developing the app. It is front-end development. And app.js is also web application part. So this index.html include app.js and call this JavaScript. And in this app.js, I emphasize 3 parts. Box 1 is initialize Ethereum provider. As I said, I use the web3.js. So web3.js is an Ethereum JavaScript library. So we need to initialize Ethereum provider to connect to Ethereum. So HTTP browser is very popular provider in web3.js. And so that's it. And MetaMask will call these functions. And then box 2 is initialize contract instance. So Web3.js provides some functions to create a contract instance to interact with a contract. And that's it. And box 3 is called the bolt function from a MetaMask account. So this page will be run on browser, and this browser will communicate with MetaMask to call smart contract function. So MetaMask will inject Ethereum provider into browser and then call these kind of functions. So yeah, but I don't want to explain in more detail in this web application, because in next part of today's lecture we will address Ethers.js. It's more popular right now, so I will explain Ethers.js in more detail. Okay, we have web application part. So next step, we will deploy and test all these components in local computer. So if we need to test our web application and smart contract, we need to set up test accounts in MetaMask. When you install your MetaMask, you have maybe you have Ethereum network or testnet network, but you don't have local network like Ganache. So you have to add network in MetaMask like this, so you can follow this page. And also you have to import accounts from Ganache into MetaMask. It's not that difficult. You can copy private key from Ganache and then copy that key into MetaMask to import that account. Okay, I will show you some demo. This video shows deploying and test all these components. Okay. This video shows deploying and test all these components in a local environment, local computer with Truffle, Ganache, and MetaMask. At first, we already wrote some web user interface and web application, index.js and index.html like this. And index.html includes app.js. App.js is a main JavaScript file to interact with smart contract. So there are many Web3.js related command and script like this. Okay, so we already deployed our parallel smart contract into Ganache chain, and then so we can start web server npm start with our script.
Okay, that's it. And we will connect to local host this page. Before that, we have to configure our MetaMask. So I already connect to Ganache chain like this. This is Ganache chain, and I import for different account of Ganache chain. So that's not that difficult to add Ganache chain account. For example, if I want to add one more Ganache chain account, like account this one, I can copy private key, and then in MetaMask, I can import account with this key. Okay, that's it. So you can add one more. I added one more Ganache chain account. Okay, I need to change this account to the first one. It is a chairperson's account. Okay, so I'm ready to learn web front end. So localhost, that's it. So I connected to this account, and then current account is like this. This is the same address of this account 13. So let's test this online borrowing application. So firstly, you need to register another account. So the second one, I register second one with this one, and MetaMask pop up, and you have to confirm this transaction to register with a small gas fee. Okay, it's done successfully. And then second one as the second account and register, and again I confirm this transaction. Okay, so you can this transaction with Ganache chain in transaction page, so you can see this transaction come from this account, and then input is this account address. So it's very convenient. Okay, let's move on to next step. Next step is boarding page. So move to next page. So in this case, you should be in chairperson's account like this, and then move to the next page, and I confirm this transaction. Okay, borrowing started. So chairperson bought for what is this? Bought for pizza. Okay, and confirm. Okay, well, successfully. Okay, you have to if you want to bought with another account, you have to change your account in MetaMask. So next one is 14, and you need to reload this page and account address, change it, and then bought to pizza. Okay, and change the account to the third one, 15, and reload and change the account. account and bought for gimbap. Okay, confirm. Okay, done. So we finished voting. So we have to move our page to voting done. So you should change your account to chairpersons. Okay, this is chairperson and reload. Okay, and move to next page. Confirm. Voting ended, and anyone can request the winner. So who is the winner? What is the winner? So pizza is the winner. Okay, that's it. We are done to deploy and test all these components into local environment.
Okay, let's get back to slide. Where is the slide? Oh, okay. Okay. Wow. 1, 2, 3. Okay, okay. Okay. So as you can see, it's a little bit complicated to test your application with MetaMask because it simulates multiple users in a single laptop and single MetaMask. So it's a little bit complicated to test these things. So, I think it is very different from traditional web development. So, okay. So next one is finally we can deploy our smart contract to real environment. Actually, testnet is also real environment because we will use real Ethereum, even though it is a testnet. So we will put our code into remote computer, remote testnet computer. So we are done web application part and blockchain smart contract part. So remaining is deploying smart contract into testnet and mainnet. There are 3 different Ethereum testnet, but the recommendation is Sephora because Ethereum Foundation recommends Sephora, and you can easily get Sephora test Ether very easily. But in other case, it's a little bit difficult. So you need to use Sephora. So in this step, we don't write any another program or code, but we need to configure some environment to use Sephora. At first, we have to add Sephora to MetaMask, but it's not difficult because you can change configuration. There is a configuration about showing test network. So if you turn on that configuration, you can see Sephora test network. Or if you want to add it manually, you can put this information into MetaMask. And you have to get free Sephora Ether for gas fee. When you call a function, you need a gas fee. So it's not free anymore. So you need to get free gas fee from process service. There are some process service I wrote to main process service. You can get free gas. And you need to prepare an RPC node. Even though we developed the app and we run web server in local environment, we need RPC node to communicate with Seporia testnet. So RPC node connect DFs to the blockchain, and RPC node analyze JSON RPC protocol and then core Seporia testnet. There are 3 options to run an RPC node. First option is using an RPC node provider. There are some providers, Alchemy, Imperial, and Oldenode. Oldenode is Korean RPC node provider from what is it? The company names. DSRV. So they provide this kind of service. So you can choose your RPC node provider. And I use Alchemy as an RPC node provider with a pre-tier. We can use pre-tier without any fee, without any payment. So I recommend to use an RPC node provider. The second option is use a public RPC node. It's public, so it's free, but it has some limitation on resource. And the third option is run your own RPC node in your server or in your cloud. But as you can see, it has a lot of work. So as a beginner, I recommend to use an RPC node provider as a pre-tier. And next step is deploying contracts to Seporia. So we need to modify some configuration file. In this case, we need to modify truffle config.js. So I add Seporia part. When we connect to RPC node, we need RPC node's URL and also private key of my account to call to deploy this contract. So I put that important information.env file, and you cannot read that information. And then you can deploy your contract to Seporia with the truffle migrate network Seporia. Then you can check the result with either scan. Finally, we can use either scan to check our contract and our transactions. So, and then we need to run web application with contracts in Seporia. So you need to modify app.js with an RPC node. So you need to change URL to connect URL as an RPC node like this. Okay, and npm start. And then we will get a web page. Okay, I will show this demonstration and then we will have a short break. Okay, video 4. Okay. This video deploying and testing smart contract into Seporia testnet with truffle. At first, you need to add Seporia network configuration into truffle config.js. This is it. So you need to write RPC node URL. This is Alchemy RPC node URL, and also you have to set up private key of your contract, your account to deploy contract. So if
when your account have to hold a separate test is like this. This is mine, and I have separate is. If you don't have, you can get free separate is from process service like this. Okay, so we ready to deploy smart contract to separate network. So let's deploy. Let truffle migrate reset network separator. Okay, let's do that. It takes more time than local environment, deploying to local environment, because it is a local server, it is local remote environment. So, and it's real blockchain environment, even though it is testnet. Okay, it is kind of simulation, and currently deploying contract really. Okay, almost done. This is contract address. Okay, it's done. So we can check deployment with either scan of separator. So this is new account, new contract account. So you can see like this. Okay, so we are ready to run web server npm start. Okay, and connect to localhost and refresh. So this is chairperson's account. Okay, and the first step is registration, and copy our account address and register and pay for gas, confirm, and wait for some minutes, some second, because it is a real environment. So it takes time like this. And you can check. So it is pending currently. So we are waiting for complete this transaction. Okay, okay, it's done. I don't know, there is no transaction. Why? Okay, we have one. So it's real. It's real. So it's not perfect because Ethereum environment is developing progressively. So we have some errors, some mistakes. Okay, so let's move on to next page. And I need to pay more gas because it takes, we have to reduce the time. Okay, confirmed. Okay, so we are voting step, and chairperson vote for sushi. Okay, and more gas P and confirmed. Check either scan, pending. Is done. Okay. We will get back later. So, and change the account to the second one. This is the second one. And vote for kimchi jjigae. Okay. Before that, we have to refresh and vote for kimchi jjigae. Okay. And increase the gas P and confirm. Okay, done. So, and move to vote done page. Change the account and refresh. And move to final page. Okay. So let's check. We don't have that transaction still. Okay. Okay. Boring ended. So it is a real environment. So we cannot get the response immediately. So we need to wait for some time to testing to test this application. So finally we will get the winner is sushi. Okay, this is the end. This is the end to deploy and test your smart contract into testnet.
Okay, we are done. This scenario. So we are 5:30. So we will have 10 minutes short break. So we will come back to 40. So let's have a break.